Hi, my name is Spencer Maley, and my experiment was over salt water and the effect on boiling water. So, for this experiment, and for this presentation, the question that I came up with was that currently, right now, we're running out of fresh water in the world. The reservoirs are drying up as more and more people need that water to survive. Solutions are being made around the world about what to do about this problem when that time comes that we eventually run out. And in Africa, many places are trying to boil the salt water and condense the vapor, which is pure distilled water. So I wanted to conduct this experiment in a small setting, and in this PowerPoint, I'll analyze the data and imply what that could mean for the future. The research question that I asked for this study was, does distilled water or salt water boil more quickly on a stove? For my method, I had my procedure. My procedure was that I took 500 milliliters of distilled water, added it to a pot. The pot that was used in the experiment is on the left. I'm currently not at my lab, and I'm home. And then the stove that I used was on the right. On this stove, I used the top right burner, and I used it at the highest setting. So I took the distilled water, added it to the pot, and then I placed it on the burner, turned on the stopwatch, waited for it to come to a rolling boil, paused the timer, turned off the burner, set the pot aside, recorded the data, and then I waited in between. And then in the other set of trials where I compared it to salt water, the only thing that I changed is that I added salt to the solution at 170 grams per 500 milliliters or 340 grams per liter, and I stirred that with a spoon to then mix it up. For this experiment, the independent variable is the amount of salt in distilled water. Those are the two things that is the thing that changes over the two sets of trials. The first set of trial obviously has 0. The second set has 340 grams per liter or 170 grams per 500 milliliters. And the dependent variable off of that is how much time it takes to reach a rolling boil. This experiment is very simple. It doesn't require energy conversions or boiling point elevation conversions. It's just the amount of time that it takes is dependent on the amount of salt that's in the solution. The hypothesis that I derived from this was that I thought that salt water is going to take longer to boil than distilled water. Here are some videos to back it up, what I was doing in my methodology. This is the timer that I used. It was on the iPhone. I would simply start the timer, then I'd lap it to show how long it was taking to rest, to keep track of that since it needed about 30 minutes to cool down, and then I'd lap it again to start my next one when the burner was taken in the correct place. This is what is defined in this experiment as a rolling boil. Although water is clear, and if you add salt water to solution, it only makes it cloudy, the bottom of the pot is going to be relatively visible at all times. However, the plane of the rolling boil is not going to be, and that's what I was looking for when defining the rolling boil, that it was boiling so viciously that you couldn't make out the flat plane at the bottom of the pot. From this experiment, these are my results. As you can see, the difference between means, with distilled water being about 260 seconds and salt water being about 300 seconds, you can see that salt water increases on average about 40 seconds more than distilled water. Both experiments had a variance of around 10 seconds, which shows that there's a pretty high accuracy and precision to the study. And then for the best fit p-test, or t-test, is a one-tailed t-test, and that generated a p-value of less than 1%, showing that this experiment is most likely not due to randomness. From that data, the hypothesis is upheld that it does take longer for salt water to boil than fresh water and distilled water. The research question is answered that salt does raise the boiling point as of the mean increase between salt and fresh water. And then from this experiment, although there is not enough research to correctly determine, it does, with only a difference of around 40 seconds, it could be a good alternative for fresh water. Some limitations that I had in this study was that I couldn't use real salt water. Being in Kansas, there's not an ocean where I can go scoop it up, and I didn't have the budget in my study to go out and ship in samples of ocean water. So using ocean water would be more accurate to what this study intends to solve. Obviously, working out of a regular stove with a regular cooking pot, I couldn't capture the amount of volume that was actually needed for something of this level, as nobody needs 500 milliliters of water. People everywhere need millions and millions of liters of water every day. And then the equipment wasn't very effective for that same thing of larger samples. Things such as boiling pools and electrode rods would greatly help. In the future research could include things like larger sample sizes. Again, people need lots of water. It's not just 500 milliliters at a time. This is government level implications. Using ocean water with all of the molecules and other impurities inside that water would get a better understanding of the change in boiling time between that and of fresh water. And then the cost breakdown would really help more the economic side of what this experiment and study is trying to solve, as equations such as energy conservation and then the cost of that energy would greatly help further see if it's a good solution. And then, wrapping up, could the world be saved by boiling salt water? Maybe. There's needs further research, but the results of this study are promising and could be the solution. And then here are some of the articles that I cited.